Hey there, guys. I'm going to try and go through some of the mathematics analysis and approaches book today, the higher level course companion from Oxford. And this video is just about telling you essentially what you need in order to start and a little bit about what's turning up in the chapters, maybe a bit about the difficulty of it, and maybe a bit about what's in chapter one, but I'm not going to do any actual exercises in this particular video. It's just an introduction. Okay, while I've still got the video on, you're going to need a calculator. Put this on here. This is the calculator which we use. So this is the TI Inspire CX model, not the CAX model. I believe the CAX model does some kind of algebraic manipulation, which you're not allowed to use in the exam. So this is the best calculator that you can get for the exams. Although I'm sure there are Sharp ones and Casio ones which are pretty good as well, and other models. But for our school to be consistent with what the teachers understand and what most of the students have, there'll be a lot of students teaching how to figure, once they've figured out how to do things, they'll be teaching you how to do things on these calculators as well. So it's a good idea to all have the same one, and that's the one which we have. Okay, it looks kind of like that. Some of the colors are different now. Sometimes you get red, black, and white ones. But this one's a few years old. Okay, let me just show you that as well on. Yeah, I'm busy making lots of videos. Okay, let me show you that on here. Let's get rid of me. This one here, if we go to noon.com, I'm not saying it's necessarily the best priced. Here we go. This is the version which you need. The TI stands for Texas Instruments Inspire. So not Inspire. CX, yeah, and not the CAX one. Definitely not that one. Okay, maybe the CX one is there just to show you which one you shouldn't have. See, let's just load that one up. Yeah, the one with the CAX, because you see sometimes students get these ones and they're really expensive. And they have the CAX and they're kind of all black with a bit of gray on it. Okay, anyway, so that's what you're going to need. A graphics calculator, what we call a GDC, a graphic display calculator. It can do graphs. It can do lots of stuff which Excel can do. It can do a lot of statistics. Yeah, they're pretty useful. Okay, so this is only just a brief introduction anyway. So let's look a little further down. Lots of introductory stuff which I'm just skipping over. Let's have a little look. So we're going to have a look at chapter one. This one's called From Patterns to Generalizations, and they've chucked a whole load of algebraic stuff in this first chapter. And it seems like there's only 4 sections. So that would be pretty easy to fly through. But you'll realize as soon as you go through the sections that it gets difficult quite quickly. Yeah, so this goes up to chapter 11 there. Let's just have a look at some of the chapters here. We have representing relationships, so more on functions, expanding the number system to complex numbers or imaginary numbers. Measuring change, we've got differentiation turning up, which a lot of students will have studied already, or at least some of. Obviously, we'll extend it further. Then we're getting to some statistical work here. We've got analyzing data and quantifying randomness. And relationships in space, so geometry and trigonometry. There'll be a lot of extension to trigonometry in this course. Then we have more kind of number work here, exponentials, logarithms, and lumped in with that is integration. Integration is being the reverse or the inverse function to your differentiation. Integration and differentiation go together to form calculus. Let's have a little look. We've got more calculus in here. Fantastic. Kinematics, for example. Some people might have done some of that in physics already. It's just about the motion of particles. And then we've got some vectors turning up. What else do we have? We have planes, equations of planes will turn up there as well. We have complex numbers, furthering of complex numbers, and some distributions which they're talking about here. So some more statistics at the end there as well. There's some classic stuff here, normal distribution, binomial distribution, and so on. Okay, so let's just have a quick look at what's in chapter 1. Okay, now I'm only going to go through the worked examples. Obviously, you need the book in order to go through the questions from the exercises to get sufficient practice, and even that might not be sufficient. You might want to get another book which covers this course as well. And there are various other companies who produce books for this, including Cambridge. Yeah, okay, well, let's not go into that now. Right, so let's just have a look at this chapter, chapter 1. So chapter 1, there's loads of stuff in this. There's sequences and series. Some people would have done work on this before, of course. Sequences will have arithmetic sequences, recursive definitions for sequences, sums of sequences, in other words, series. We have geometric sequences, and lots of people would have done work on that before, including using some sigma notation here as well. And once that's all done, that's a fair bit of the first part of the chapter. A few little proofs going on there as well. And let's just get a little past that. From there, convergent and divergent sequences. And that's up to 1C. Let's see if it goes on beyond that for 1D. Now 1D, that's still sequences. And then we're talking about proof afterwards. So we come on to proof, and I believe it's proof by contradiction to start off with. We talk about some basic proofs. You can see there's lots of examples, which I'm going to go through, the worked examples. So here we go, some proof here. Also, some general proofs here. Okay, so for example, prove, here we go, show that the product of two odd numbers is always an odd number. Okay, and we'll set that up and solve those ones. But then we're talking about proof by contradiction. So, for example, show that the square root of 2 is irrational. We'll need to talk about types of numbers as well in order to know what irrational means. So we'll need to talk about the number system. And then we have proof by induction, which in the former HL course would have been much later in the course, but now they've put it early on. So this is a difficult topic early on. So it's proof by induction. Lots of different types of examples for proof by induction, though they've condensed it here into just one exercise. Okay. Beyond that, we have the binomial expansion. Some people may have done that already. So we're talking about, in brackets, a plus b all raised to the power of n. So expansions of brackets which go beyond quadratics. So quadratic brackets where you would have two brackets timesing together. Here we'd be looking at raising brackets to the power of 3, 4, 5, and so on. So we'll need to deal with some of that. And then you have some counting principles turning up later on, which is talking about, there's really nice questions, some of these. How many ways can the letters of the word candle be arranged, for example? So we're talking about permutations and combinations later on to finish off this chapter. I believe that's where this chapter ends at 1H. No, it doesn't. It goes beyond because it deals with the binomial theorem as well. Okay, so binomial theorem. We're talking about, again, expansions of brackets like this. Okay. Oh, generalization of the binomial expansion also turns up in this chapter. So here we're talking about negative integers and a generalized expansion in this case as well, and potentially fractional integers. Okay, yeah, there we go. Fractional integers on this one as well. Yeah. Okay, and that will take us to the end of the chapter, I think. Let's have a little look. Yeah, that takes us to the end of the chapter. Okay, that's just a quick review. In my next video, I'm going to go through the examples before 1A. Thank you for listening to this, guys, and hope you continue to the next video.